The sun is breaking through here on Rhode Island's Narragansett Bay. A good day for the beach. Hold off on the bathing suit, though. The water along this stretch of shore is looking a little too, well, thick and green for swimming. But that's okay with University of Rhode Island marine ecologist Carol Thornburr and her team. In fact, it's the reason they come here.
So my research has been really driven by the questions of how do humans, and in particular global climate change, impact our coastal systems.
With support from the National Science Foundation, they're learning how marine life is faring in the changing climate, specifically macroalgae, or as most people say, seaweed. And it's not just here. Macroalgal populations regularly spike or bloom all over the world.
They can start to cause problems for humans, both in terms of aesthetics as well as fisheries, a lot of other economic considerations, when they grow and form just very dense accumulations that either sit in the water or wash up along the shoreline.
The group has been coming back to this little strip of sand and others regularly for more than a decade.
We count what different species are there, what we call the percent covered. If you look at the ground, is it completely covered with seaweed? Is there just a little bit in different spots?
They want to know how the blooms affect fish stocks and oyster beds, as well as how nutrients in the water from sewage treatment and agricultural runoff can feed them and make them larger.
One of the big things that I'm trying to answer is what causes these blooms, how can we potentially limit formation during the peak bloom forming periods, and can we obtain any predictive values so we would know when a bloom might occur.
They're also interested in what happens when large quantities of seaweed wash up into wetland areas.
So the tide comes up, the algae comes up with it, and then when the water goes back, the algae lots of times will just get stuck.
Normally in a healthy salt marsh, we have a lot of greenhouse gas absorption. So a lot of carbon dioxide is being absorbed in salt marshes just because it's a very productive habitat. There's a lot of plants.
With the help of some heavy-duty equipment set up in the marsh, they put this chamber down to measure the greenhouse gases that come off the plants during normal times and also during algal blooms. They found the seaweed can smother the vegetation and then die and start decaying, releasing CO2 into the atmosphere.
So instead of being a carbon dioxide sink, which is a very important aspect of salt marshes, it might potentially become a carbon dioxide source.
And they stake out little cages of seaweed next to each other just offshore to find out how different kinds of macroalgae interact with each other.
And so what we're testing here is whether compounds that are produced and released by the green seaweed can inhibit the growth of the red seaweed. We've shown this in the lab and now we're testing it in the field.
Thornburr says understanding the dynamics of macroalgal blooms here will have payoffs far beyond Narragansett Bay.
But really we're using it as a model system so that we can better understand on a global scale how these blooms form and how we might be able to ameliorate their impacts going forward.
Research on the edge, getting down in the weeds, so to speak, on impacts to our coastal systems. They've got this one in the bag. For Science Nation, I'm Miles O'Brien.